Wood, Characteristics, and Joinery. Hi, I'm Jim Vanderscaff at Down East Wood Art, and welcome to my shop. Today's topic is joinery. How do we make these joints? What are the joints? And why do we do what we do? Let's start off talking about wood. Wood comes from logs, as you can see here, and these logs are cut horizontally, and you can see the picture of how different methods of cutting these logs are. First of all, flat sawn. Here's a picture of a flat sawn board, and that's defined as the annular rings are generally 30 degrees or less to the face of the board. So these rings are 30 degrees or less. What happens with flat sawn is when they dry, as shown in this picture, the board tilts or cups up toward the outer bark, and that's one problem with flat sawing. The next technique is called rift sawing, and rift sawing cutting boards from logs so that the grain is between 30 and 60 degrees to the face of the board. So this annular rings is between 30 and 60 degrees. These are all, these two are rift sawn techniques. What's the next technique? Well, the next technique is rift sawing, quarter sawing. Quarter sawing is cutting boards so the grain is between 60 and 90 degrees to the face. Here's one that's 90 degrees, this is 90 for the most part, this is 90 for the most part. What's the benefit? Well, the benefit is the wood just expands out and shrinks back in like this. It doesn't cup up like this board, or cup slightly like this board, and so it makes a big difference. When you quarter sawn wood, you basically cut the wood log into quarters, and then you cut out the pieces from those quarters, and hence there's more loss when you're making boards like that than if you do it flat sawn, because flat sawn you just go all the way around the log regardless of what the angle is. So that's how we get the boards. If you think of wood as a collection of straws oriented with the grain of the wood like this, a whole series of straws, that's a nice way to think about it, because if you think about gluing to the end of these straws, which is the end grain here, it doesn't work very well. But if you think about gluing to the straws when they're all oriented like this, and we're gluing on this surface or this surface, it works very well. And there's some reasons for that. Okay, so joinery. What do we do to glue boards together? Well, I've mentioned before that if I glue two boards like this with their end grain, that's the straws coming together. And if you put glue on there, that joint is just not going to be very strong at all. If I glue the boards together this way, that's entirely different. I'm gluing this glue joint with just glue applied will be extremely strong. But of course, that's not how we do things for fine furniture across the board. We have to end up bringing the boards together in a number of different ways. One of those ways is called a mortise and tenon. And this is the mortise, this is the tenon, this is, in this case, it's a floating tenon, and there's another mortise on this side. Those pieces are brought together. Glue is placed on this portion of the wood, the tenon, on both ends, and when that's glued together, that's an extremely strong joint. What's another way? Well, another way is to use dowels, and dowels are little mini tenons, if you will, and we can put that in both sides of the piece of wood, both pieces, and then we bring that together and we got yet another joint. That's a dowel joint. So what are the other kinds of, and how do we cut these? Well, there are a variety of ways to cut these joints, and you can basically cut the mortise with a router, You can cut it with a mortising tool. You can cut the tenon on the table saw. You can cut it on a router. There are a lot of different ways to do that. So we've covered mortise and tenons. Here's one other joint. It's called a lap joint. We'd use it if we were going to bring boards together like that. It's quite strong, but we've cut the strength of the wood to half the thickness by virtue of making that particular cut. A mortise and tenon joint is really stronger, but this is another way to do it. That leads us to joining boards in another way. We can use a thing called a biscuit, and a biscuit is a cut like a mortise into the board on both sides of both pieces of the board. They slip into place, and then the board is glued together. I don't find them particularly useful for this kind of application because the joint is so strong this way. It's really doesn't, you don't need anything more if you're going to join the boards like this. Some people say it helps with alignment, and that's true, but I think other techniques are better used for that purpose. What other kinds of joints are there? Well, there are things called box joints. Box joints are just cut like this. This is a 1/4 inch box joint, and they're cut with a jig, and they match up, and there's a tremendous amount of glue surface. You see them on boxes, small boxes, that kind of thing. Other joints. The beautiful dovetail joint. As you can see, it looks like the tails of a dove, and it's joined like this together. This was cut with a jig, and you can see it fits quite nicely together. It has the greatest strength by resisting pulling this board in this direction. If I pull it this way, that of course can slip out unless it's glued, and there's a lot of glue surface on there. So it's really a very good joint. It's also a very attractive joint. We can make dovetails that are called half dovetails, and this is another way to join boards together. It's typically used in furniture, in the drawers of furniture. One of the things I love to do is to cut dovetails by hand. Cutting them with a machine makes a nice fit up, but learning how to cut them with just hand tools is something that I really enjoy, and we'll be covering that in another video. That's a very tight fit. There is no, the method I use has no trimming with a chisel of the flats of these sides of the tails. They are cut with a saw and not touched after that. It's a very unique method, and happy to show you that in another video. Okay, joinery can get changed depending on what the purpose of it is. If we need to make this joint, let's say a dovetail joint, even stronger. Here's one. It's again a dovetail joint, and I've used it as a support up against a wall to hold lumber, with 2 screws going into the upright 2x4 in the wall. It's extraordinarily strong because the dovetail, like I said, resists pulling force this way, and then these little triangly formed pieces of wood just make that support incredibly strong. I got 50, 60, 70 pounds of wood on any one of these joints, and they hold without any trouble at all. Wood joints can get very exotic. Here's one that was done to support Sam Malouf's chair. It was modified by Hal Walker. But you can see this kind of a joint, and this was the leg of the rocker chair. It's also the support piece in back of the rocker chair, but you can see how elaborate that is. That's hammered in, it fits completely, and then a screw is placed right in there. Joinery can also involve fitting pieces of wood into other pieces of wood for contrast and for attractiveness and for artistic development. This is a piece of walnut and a piece of bird's eye maple, and you can see how attractive that is, and it's not even finished. Okay, the next subject we want to talk about is moisture-driven wood movement. What happens with a board is that when moisture enters the board, the wood expands, but it doesn't expand uniformly across the board. In this case, along the grain, it doesn't expand virtually at all, hardly anything, but it does expand across the grain both ways, radially and tangentially. And so we have to take that into account when we're building furniture, when we're putting things together, because we got to properly account when we have joints that come together. We have to make sure that if we have, let's say, on a door, and we have an additional piece of wood on the inside of the door, imagine this is the outside frame of the door, then that wood on the inside is going to expand and contract, and we have to allow for that in our frame on the outside. That's just one example. In my book, I have gone to a lot of detail in how you deal with wood movement. And I'll show you a picture of the way we make these calculations. And there's a whole table in the book. I don't expect you to read this. I just want to let you know that it's here. Okay, so we talked about wood movement due to moisture entering the wood and what direction that wood moves. Well, wood products used outside but protected from rain will stabilize with their environment at about 12 to 14% moisture content in North America. In Maine, where I live, the yearly range in equilibrium moisture content is 12.1 in April to 14.0 in November. Okay, so that's 2% equilibrium moisture content. That means that the content of the board is in equilibrium with the humidity level measured in the shop. I use a humidistat with a temperature gauge to determine exactly what that is. The other thing I use is a device to measure the wood content, the moisture in wood. This happens to be a lignobat with prongs, and the way we use it is we stick those prongs in the end of a board, and it's measured, and that showed 11% moisture content. Kiln dry wood typically is between 6.5 and 8. I'll check another board and we can take a look at that. There's 13. So let me look at another board. That's 12. These are boards that have accumulated in my shop, so they're taking on the moisture content of the atmosphere that they are in. So again, getting back to the book, what we're talking about is with that level of moisture change, we've got to allow for that much movement in the wood. And to give you an idea just what that might be, I'll give you a reference to a calculation I made to let you know. For example, using this table, flat song sugar maple will experience 5/16 of an inch movement, while quarter sawn black cherry will move 1/8 of an inch. That's a 24-inch wide panel with 4% change in moisture content. That just gives you an idea of how much moisture, what moisture will do when it's going in and out of wood. So in addition to joinery, what has the industry tried to do to make that problem either go away or be easier to deal with? Well, one thing they've done is make plywood. Plywood is put together with glue, and the orientation of the plies, the individual plies, are 90 degrees to one another, and the wood simply does not move in any direction. But we don't make a lot of furniture out of plywood. We make furniture out of hardwoods, and so we have to come up with methods to deal with that. And I'd like to show you some of those in the next segment of this video. Okay, so now before we get into how this joinery method or these joinery methods work in actual projects, I wanted to show you one more technique, and that is called pocket screw method. And pocket screws are really quite amazing. You use a jig like this, and what you do is you send a drill bit down at an angle, and then the board is here, and you can see that drill going out, and it cuts a little pocket excuse me, into the board. The board is clamped in place like this, and you cut it in like that. It creates a little pocket. That places an opening, creates an opening for a screw, and the screws look like this. There's different length screws, etc. And again, you put this driver into a drill bit, put that into the pocket screw, and attach it to the other board. And so you can do that for various thickness boards, for various woods joining together, and I'll give you an example of just how that was used. This is a simple little end table with tapered legs and a apron system and just a single board on top. And if you zoom in, you can see the little holes for the pocket screws all the way around. There's several of them, and they hold this, they hold the legs together, they hold the apron in place, they hold the whole body to the top of the table. Now, we just finished talking about wood movement. And what do I mean by that? Well, is this wood going to move with moisture content different in this line? No, because that's the grain of the wood. Is it going to move this way and up and down? Well, up and down we don't care because we're not attached. But if it moves this way, then we have to worry about how we're attaching it down below, because this piece goes across the grain of the wood here. So the table top will move, while the bottom doesn't move because this is the long grain. So why was I able to use pocket screw technique for that? Well, because pocket screws are flexible. So with the moisture content in Maine, this may move maybe 1/8 of an inch from one side to another. These pocket screws easily accommodate that. Another technique, when not using pocket screws, when you want to join a tabletop to a apron and legs like this, is to use these little clips. And these little clips are nothing more than a piece of wood, the long grain is this way, with a tab in the end and a screw, place for a screw. And one would then cut a slot into this apron and have them placed at a couple of different locations like that. The slot would be in the wood here. This little tab would be screwed down to the top, and it would allow movement in both directions. So they're used as an alternative. Joinery. You can see this was all done with pocket screws. It's very strong, very quick, very stable, but it's not the only method that can be used for that. Many other methods have been used over the years. Let me give you an example. This is an example of a shaker end table with a single drawer, and I want to just illustrate the different joinery methods here. Dovetails on all the joints all the way around, so that the face of the drawer has nothing shown. These are half blind dovetails, these are full dovetails. Then, now the next thing is the movement of the drawer bottom. This bottom is put in place, and you can see what it looks like. And again, the movement of the wood with moisture change is not in this direction, but rather in this direction. So a groove is cut all the way around here, all the way here, and then the groove is made longer than the piece of wood. A single screw holds this in place. If I took this out now, it would just slide out because it's not glued at all the way around. It just moves and floats in the bottom and works perfectly fine. So that's how you accommodate wood movement over a larger period or a larger portion of wood. The joinery on the table itself is a whole nother matter. This mortise and tenons in here all the way around on all sides. Mortise and tenons there, mortise and tenon here, mortise and tenon there. So this is extremely strong. These legs are tapered, they're made out of maple. And then on the inside of the drawer, we've got a mortise and tenon joint here, and here we've got a dovetail that shows this piece is tied in, and then the drawer just slides in place and is attached to the top. Here I chose to put a single screw in place because this table, this top, was absolutely flat and we didn't need any more support to it than that. Other joinery methods. Here's another example of a box joint. You can see two different types of wood, walnut and maple. I'm sorry, walnut and cherry. And this is a wood hinge, if you will. You can see that it just disappears as the lid opens and closes. It's another example of one here. This is all made out of poplar, and again, this is box joints with different sizes. And there's the wood joint again, the wood hinge. Here's an example of a miter joint. We haven't talked about miter joints, but they're cut at a 45-degree angle. Again, this is end grain to end grain, so it's not a very good glue surface. So what we do is we cut little mitered slots in here and put in a piece of wood across that miter joint on all sides, and that holds it extremely well. It's got a little bottom that's cut in a groove and slipped in place. Another example is dovetails with a little box of, this happens to be maple and walnut, and then a top that just fits on top like that and locks in place with a beveled edge. So those are just some examples. One more thing that I want to show you, if you can look over here, Alex, is here's an example of what you can do with the entire cross section of the log. Usually when I did live edge work, I cut the bark off, but in this case I kept it attached, and in certain places I had to glue it back on, but I just think it's beautiful. This happens to be cherry, and it's just a gorgeous piece of wood that shows the entire cross-section of the tree. This is just an example of 3 little shelves that you can use for knickknacks, and that's why that was put together. But just another example of the need for string as joinery. Okay.